Hello, guys. March, how are you doing?
Yes, sir, we can hear you.
So you get the experience of network challenges with IME.
I am breaking up.
What causes the flow of electricity in an electric circuit?
Causes
I
the
can't hear
circuit. The circuit there. Let me see. Was it capacitor or resistor?
Okay, the rules, I don't need to stress it anymore. We are doing great. We did great in the last class. And the class was quite successful. I have to sincerely, wow, my bandwidth is low. Don't worry, I'll fix it. Just waiting. Is it better? Is it very low? Just relax.
Yes.
All right. So praise God. The last class, it's been a while. I can't remember the last time I taught you guys. Like a week from today. Well, so we have to start. I think we've had enough time. Okay, so how has your chemistry been so far?
Easy compared to last term's own, in my opinion.
That.
Yeah, right.
That's very okay.
No. Yes.
It is compared to last term's work. It's actually easy.
For yourself.
Sorry.
Shit, you understand last term's work better than this term's work. You are confused.
No shit, they mean Fade.
Fadi, you are very confused.
You speak for yourself.
You can't hear it.
Emma Binu.
Morning now.
All right.
Sorry.
Well, uniquely, let me just tell you one unique fact. Chemistry this term, for now, let me just tell you, for now, is a bit easier because it will still get harder. It's a bit easier for now. At least they are still doing
Why?
the basic aspect of the chemistry, water, solution. Anybody in SS3 you ask about all this aspect of chemistry, they be like, that's beans. So I just hope that you guys will understand it and it will also be beans for you. Well, I hope you have been reading the notes. And it's time for us to start our lesson.
I haven't seen the note.
Come on, that's not true. You've not been checking on the Microsoft team.
I just checked it today, so I didn't.
I tried to try and refresh your stuff. You'll find it there.
Thank you.
Just casted yourself.
Just refresh it. You see chemistry notes, the videos, and the notes proper itself. Okay. All right. I have to apologize sincerely to everyone.
Because you exist.
Our work last term.
This place is so. Who is talking?
Sam, don't mute your mic.
I have to apologize to all of us. Last week work, I couldn't upload it. By the time the lesson finished, I tried to review it. I just discovered that all along I've not been recording. It was very, very painful. And I felt like I nailed that class. But never mind. The other videos attached explains, should be able to explain it better. So as usual, please use the chat section of this of this software for your questions. Send it at the time you feel that you need more clarifications. Okay, as we progress, I will just be responding to it as necessary. All right, so from feedback from Mr. Fayemi indicate that you guys are done with hardness of water, temporary hardness, permanent hardness. You'll be able to look at how to control water pollution. You've also learned how advantages and disadvantages of hardness of water, which is quite good. So this is what you have done so far is the easiest chemistry for this SS2. I can't lie. Maybe apart from doing what is the easiest other one is? Yeah, apart from doing entropy and enthalpy, free energy change, rate of reaction. This happens to be the next easiest topic we have doing so far. But after all this aspect of chemistry, we will be balling right all the way to organic chemistry. Yeah, for those of you feeling that I couldn't handle it, actually what happened was as I continue the day's lesson, I normally record. Sometimes I try not to record the interaction between me and my students so that it will be a little bit professional when you're watching and listening to the videos that are. But unfortunately, so I usually pause and I'll continue recording. But today, trust me, I'm sure you can see on your screen it's showing recording. All right, so without wasting much of our time, so we'll look at false and true solutions. Yeah, in SS1, when you were about dealing with acid, bases, and salt, you learned about solvent, solution, solutes. Fine. So a solute can be a solid, take note, it can be a solid, can be a liquid, can even be a gas. So a solvent can be a liquid or it can be a gas. Can take note of it. A solvent can be a liquid or can be a gas. But a solute can be solid, liquid, or even a gas. So when you bring in a solute and a solvent, it usually gives you a solution. Take, for example, you take a spoon of sugar, that is a solute. You dissolve it or you add it into water, water becomes your solvent. So when you dissolve it, it gives you a clear solution. So you say that solution is homogeneous. Homogeneous because the solute and the solvent mixed completely. Another person decides to go and say, okay, since you are talking about everything is solute, you take a starch, there's this solid starch. You now decide to also use water and you mix both of them. After you finish mixing, you also formed a solution. But you could see here that it didn't really mix properly. You can see differentiate between some of the particles of the solid. So that means you do not have a complete homogeneous mixture. What you have is a heterogeneous. Homogeneous means they are the same, completely mixed. Heterogeneous means that there is still some disparity, there are still some layers between them. So sometimes we have a homogeneous mixture, we call it a solution. Okay? But when we have a heterogeneous mixture, it's also a solution, but it's a heterogeneous one. So in some cases, so those heterogeneous mixtures are called colloids. You can see on the screen colloids. So you can see an example of a colloid is your starch solution. And it's actually true. Even if you take liquid starch, by the time you spray the liquid starch on your black t-shirt and spread it, check what will happen. After, when it's dry, you obviously see some particles like, you now say, you know, the one that starched it, you know, those kind of stuff that you do at home. Yes, because starch is a colloid. Another one you talk about is your glue, your gum. Your gum is also another example of a colloid. Your milk solution is also another example of a colloid. Your perfume also is also another example of a colloid. Think about it. Even one of the easy. Okay, so also think about if my network is slow, just please ensure that you indicate on the chat section because I'm having a call that is stopping me now. Okay, so think about your egg solution. Yeah, I think I remember that. The egg white. When you want to fry egg, you crack the egg, mix it together, stir. Do you think, yes, some perfumes are sometimes clear. Yes, that's what we are going to. Yeah, when you mix your egg solution, is it usually completely homogeneous? So those solutions that I've just mentioned are called false solution. Another name for false solution is colloidal solution. So in true solutions, the particles dissolve such that, so I'm going to answer that question. How is milk heterogeneous? I'm coming to answer that. In some solutions, particles dissolve such that they're able to get in between the solvents, resulting in a homogeneous mixture. That's the true solution. Okay, so let's talk about colloidal solutions. I'm going to answer those questions about milk being a colloid. We have different forms of colloidal solutions. Different forms. Yeah, let's just differentiate before I start talking about that. Let's differentiate between false and true solutions. Yeah, in false solutions, the particles are larger than those of true solution, but they are not large enough for it to be seen with a naked eye. That's what we call centrifuge in chemistry. Like your blood, when you get whenever you have a cut and your blood, maybe sometimes you have, say, a gush of blood, is it usually homogeneous? Obviously, it looks clean. It looks like it's a simple substance. But remember, your blood contains different things, minerals, platelets, and some other cells. So you can imagine your blood. So is it possible for us to separate those components of blood? Yes, very easy, by the use of what we call a centrifuge. A centrifuge is a machine that when it spins, it's just like when you are stirring your milk solution, you are stirring. So you stir around, right? Rapid stirring. And when you keep stirring, what happens there? You now see those tiny particles, they will now come and form at the center. Even center when you watch Batman and Superman cartoon, and some alien invaders try to come on and try to take over the earth. There's this tornado is something that usually spin around. At the end of the day, everything now shifts to a bottom. But that's how centrifuge does. So when you want to separate the components of blood, you use a centrifuge. So if you want to separate the components of a colloid, you can use a centrifuge. So I'll go to show you a picture of centrifuge machine. Okay, so right now, let me just show you how the centrifuge machine looks like. For those of us who don't have a centrifuge in town, so you can see these are different categories of centrifuge machine. Let me just allow you to view this. So by the time, it separates the various centrifuge separates the various components of blood, so you can get your different platelets from the blood. Okay, I'm trying to show you. This is how the centrifuge machine looks like. So it has different cells. You can see. Let me take this one. You can see it has 1, 2, 3, 4, 5, 6. I work with a centrifuge machine one. I used like some few years back. My current research does not really need me to be separating mixtures. Remember, centrifugation is one of the techniques that we use in separation of mixtures. Okay, so that's let me. Oh God. All right, let me just copy this one. So let's go back to our notes. So I will not digress too much. Okay. So yeah. So I will show us a picture of centrifuge in very soon. All right. So let me paste it while I continue my lesson. I just hope this will not go hang now. So let me increase it. So yeah, I think I like this. I like what you can see what I'm seeing. Centrifuge. Yeah, that's the correct spelling. That is the machine. So what actually happens is that if you have a mixture like your milk, you have to be sure that there are actually particles in your milk. If you have a medical doctor as a parent, just ask them about centrifuge. They could have it in their lab. So what they simply you just take that your milk solution and put it in this centrifuge and turn it on. Maybe you turn on using this power button. You set it, it will spin for a particular number of times. When it spins, you see that the particles that you cannot even see in the milk will all clog together, and you can use your spatula and gush it out. So that's what we talk about colloidal. So let's just differentiate between. So what do you say a centrifuge is? I say a centrifuge is a machine that we use to separate mixtures of solid from a solution. Remember, we used to use filtration, but when the particles are very, very tiny that they can they can pass through the filter paper, that means does it mean that you cannot separate it? No. So we use a centrifuge machine. Okay, so that's how we said the difference between true solution and false solution. True solution will pass through filter paper. False solution can pass through filter paper. Can you imagine? So both of them can also pass through filter paper. But can it be dialyzed? A true solution can be dialyzed. Now, what do I mean by dialyzed? When a solute passes through, diffuse through a semi-permeable membrane. That's what. Let's say, for example, your clothes, your skin is a membrane. So if liquids, true solution can pass through your skin. One of the vaccines that what they are trying to produce in was that US? Yeah, that was US. What they did was just to put the in the form of a sugar substance. They put the vaccine on your skin and to just diffuse through your skin. So that's a true solution. But false solutions cannot pass through your skin, so can't be dialyzed. Then also there's what we call solutes do not scatter rays of light. If you want to check for, you can do this at home this night. Get a clear glass of water. The another one, clear glass of your liquid milk. Put them on the table and use the flash of your phone and place the flash of your phone on the two and see if the ray of light that will come out of the water and the ray of light that will come out of the milk solution will be scattered. If the ray of light that come out of the milk is spread, is scattered, then that means it's a false solution. You can do that. So is it powdered milk? You can use powdered milk. You can use your cream milk, your normal milk, liquid milk. Okay, so that's the difference between false. We like the question we Mr. Nkwocha ever give you this kind of question? I doubt. It's too elementary. I can't be giving you the difference between false and true solution. But perhaps by the time Mr. Fine to give it to you, obviously, we'll just pitch you before you can feel. But it's all right. It's okay. I understand. All right, but it's good for you to know because by this time next year, some of you will have done jam, so you have to learn them. Okay, so suspension. Look at this one now. What is the difference between suspension and a false solution? What is the difference between suspension and a false solution? Suspension is like your mist mag. You know that ones that do not mist mag that usually go to the recovery whenever your stomach is paining you, they will give it to you, and after they've shake it, they'll give it to you. When you finish drinking it, some of the particles will still stick on your lips. That is a suspension. It's not a solution. Milk, a liquid milk will not stay on your mouth, will not stay in your mouth. But for a suspension, the particles are large enough to be seen with your naked eye. But for false solution, the particles are not large enough to be seen with your eye. Okay, so that is quite interesting. So that is just for you to be able to know that true solutions is different from colloidal solution, and it's also different from um, suspension. Somebody was asking me, milk, how come milk is a colloidal solution? So like I said earlier, we have different types of colloidal solution. Yeah, you got could be a suspension also. So can we say liquid milk is a suspension since it has particles in it? If your liquid milk that you have, it's not that liquid milk is a colloid. It's the powdered milk that did not dissolve properly that you can describe as a suspension, or even your Milo, because when your Milo settles down, you still see it at the base, so that's a suspension. But when the solution is clear, I cannot even see any particle. It can be in form of a colloid, like your perfume now. When you spray your deodorant on your body, you don't really see anything. So will you say that is a true solution? No, even though it looks like one, but is a colloid. So we have three main types of colloidal solution. Take note of this for those of us that will be writing UTME in 2021, God giving us grace and life. Okay, so we have three. We have salts and gels, we have aerosols, and we have emulsion. And very simple, we have what we call the medium. Is a dispersing medium. Let's say, for example, your perfume now. Perfume is a plant extract, is a solid from plant. Some of them are in form of liquid form that they dispersed in alcohol. So that's an aerosol, like your deodorant. So salts and gels, a solid is formed when solid is dispersed in liquid medium. When you try to dissolve a solid in a liquid medium, take note, the dispersing medium is liquid, while the substance is solid. Example of a solid is your starch, your glue, clay. These are examples of salts. Funny enough, when a sol is solidified, it will turn to a gel, like your petroleum jelly cream. Yeah. Your cream. Your cream is an example of a gel. So you call it gel. Jelly cream. Jelly is jelly that, because the solid that has been dispersed in the liquid has solidified. So it is not a solid, but it's a gel. Then we have aerosol, like I've already talked about, insecticide sprays, your fog, your smoke. These are deodorants. These are examples of fog. So when the liquid is dispersed in a gaseous medium. So please take that again. Okay, aerosol. Okay, about gel. Okay, someone has to talk about gel again. Says when a sol is the liquid, the solid that has been dissolved in a liquid. That's, I don't have to be using the word dissolve. We call it dispersed. So when it means this, if you say dissolve, you may not be able to see it, but it's dispersed. It means that they are formed a kind of a heterogeneous, but you can't see it. So when you disperse it, it will form. Let's say, for example, I remember this one. During Christmas, during Christmas, or maybe on a normal weekend at home, the moment when she wants to do fried rice, she will get that butter cream. When she gets the butter cream, she heats it, it becomes in form of a liquid form. That is the sol. So when it is, that time is a liquid form. But if you take that buttercream and put it back in your refrigerator, it becomes solid. So it has solidified. That is a gel. So when the salt solidifies, it will form a gel. That's what I mean. Isn't starch liquid? Because starch is not liquid, my dear sister. In the natural state of starch is solid. The natural state, because you get starch. You talk about starchy food from carbohydrates. So the natural state is solid. So when it's dispersed in liquid, that's what you get about your liquid starch. What did you say now? Cream. Yes, cream is a gel. Yeah. Some of the cream, when they produce it, is usually in liquid form. But after cooling, it will become a solid. So it becomes a gel. Okay, so take note of that. So it's a solid dispersed in liquid. So sometimes you have a liquid dispersed in gas, like your deodorant. You spray it in the air. When you spray it, it's as if whenever you bring your deodorant, you shake it, it's as if it's liquid that is inside, but it's liquid that has been compressed. So it's liquid dispersed in gaseous medium. So when you spray it in the air, the gas travels, but it is an aerosol. So it says liquid dispersed in gas. So when you spray it on your skin, you see the liquid. When you spray it in the air, it will just be moving about, obviously. Then the last part is emulsion. Emulsion is a system where a liquid is dispersed in another liquid. Milk, hair cream, butter is a solid emulsion. So you can talk about, can see, but like I talked about butter also. When the liquid is dispersed in liquid, you get an emulsion. Or paint. You want to paint your house. Paint is another example. Okay, yeah. If you want to paint your house, what do you do? What they usually do, get a bucket of paint, mix it with water, and you paint your house. And so they usually dilute it every time. Sometimes you say, okay, mix it with kerosene. So, and you still get your normal paint mixture. That is an emulsion. Okay? Questions? I want to take questions from you guys. We have 10 minutes to the end of the class. Questions? Okay. I've already taken some of the questions already, so I've answered the questions on the chat session. Without wasting much time. So 3 types of colloid sauce. I thought you said butter is sol and gel. Okay, just a correction. Butter, by the time, because it is liquid in liquid, they have to turn all the components of the butter to liquid. So by the time the sol and gel, examples we have starch, glue, agar, jelly, gelatin, and clay. These are examples of sols and gels. But butter here. So what is the definition of this? The scattering of rays of light when it passes through a solution is what called Tyndall effect. The scattering of rays of light when it passes through a solution is Tyndall effect. Okay, so I'm still expecting. So the hair gels we use, what type of colloid is it? Emulsion. It's an emulsion. Okay. Yeah. So can you define dispersion? Dispersion in chemistry. The scattering of a substance in another medium. That's the dispersion that I talk about. You know, you talk about dispersion, the action or process of distributing. So you have dispersion of light, you have dispersion here. When you distribute substances or scatter substance, a solution, a solid in another medium. So you can talk about dispersion. So I can hear the bird making noise outside. Yes, I'm living close to nature. But okay, so your voice is cracking. Is it better now? Right? I think it should be better. Okay, so let's continue our notes, our lesson, and so we have talked about these various types of colloid. So the next thing is just some few solvents that we should talk about. Some few solvents. I love this aspect of solvents. I just love solvents. Solvents, like I said earlier, they are liquids. So liquids, solvents are mostly liquids. Some solvents can be gases also. But here, the solvents we are interested in here, we are talking about liquid solvents. So please, can you define colloid? Colloids are false solution. These are false solution obtained when a substance is dispersed in another substance. So please, can you define colloid? I've done that. Colloids are false solution which are not visible to, which contain particles that are not visible to the eye. So your note is easy to read. Keep doing this. Thank you. I appreciate that comment. Yeah. I've actually updated the notes. I don't like the fact that I don't like bugging students with too much information anymore. So, well, we have solvents. So we have different uses of solvent. We have a lot of solvent. The only solvent that most of you know is water. But thank God, at least you know water, so you know something. Somebody will go and say solvent now. I'll not be saying paint. Well, yeah, now you know that paint is a solution. So don't say paint is a solvent. So solvents can be classified into two, organic and inorganic. Or some people can call it polar and non-polar. Take note of that. Polar solvent or non-polar solvent. Take note of that. So it's either I call it organic solvent. So it is organic is the same thing as non-polar. Please take note of that. It says polar solvent are the same thing as organic solvent. But when we talk about organic and inorganic solvent, it's wide. It's just too broad to be saying. But we have polar and non-polar solvent. So then there are different ways of classifying solvent, but because they are writing just like NECO UTME, so just keep it to. I doubt you always see this question every year in UTME past question, in some WAEC past question. Okay. Uses of solvents. We have, so is polar organic or inorganic? Polar is inorganic. Okay, most polar solvents are inorganic. Remember, water is a polar solvent and water is inorganic. Water is not made from plants. All the solvent made from plants are organic. Like petrol. Is petrol made from plants? Yes. When plants die and decay, they are converted into a dark, viscous material called crude oil. And crude oil is refined to give you petrol. So technically, petrol is from plants. So polar is an organic. Polar solvents are inorganic. Okay, non-polar is organic. So we have different solvents. Let's look at their uses. Yeah, you must learn all this thing. Ammonia solution, the one that is used in making soap, is used to remove grease stains. So fats, wax. So depending on the stain you have on your clothes, you can use any of these solvents to remove it. But the most efficient way to remove grease, the most efficient way to remove grease stains is by using ammonia. Take note, is by using ammonia. Maybe while you're moving, on resumption, you just get to dance and it's clear, they just painted everywhere, and you have a paint stain on your shirt. So what are some inorganic solvents? Water, ammonia, water, ammonia can serve as inorganic solvents. Okay. So if you have a solution of borax in water is also is an inorganic solvent. Okay, so if you have a paint stain, there's an organic compound that we call it turpentine. They sell it in the market. Just ask for turpentine. Is an organic compound. You're going to do it very soon. Okay, so we have coffee stains or tea stain can be removed by a solution of borax. Just go to your chemist, they sell borax. If you go to any pharmaceutical shop, ask them you have to buy borax solution. They'll give it to you. So perfumes are obtained when oils are dissolved in alcohol. So the alcohol is ethanol. Ethanol is a suitable solvent to dissolve aromatic oils that give you very nice fragrance. Yeah. So those are bulky perfume that some of you usually use that people will be coughing and sneezing when they pass outside. Yeah, they put plenty of alcohol inside. Then your what do you call your hand sanitizer also contains alcohol. If paint has stained your clothes for more than a day, can the solvents remove it? Yes, as that's why irrespective of it. Okay, so there's also the one that we call the vulcanizer solution that they use in dissolving rubber. The street vulcanizer that is ethanol the same thing as carbonated water? No, carbonated water is not the same thing as ethanol. Okay, so vulcanizer solution is used for patching your tires and tubes. The iodine solution that used in treating your injuries is obtained by dissolving solid iodine in water. So let me answer that question. Carbonated water is not the same thing as. Let me see that question again. Okay. Is ethanol the same thing as carbon? No, ethanol is an alcohol. Okay, so carbonated water is just water containing that have carbon dioxide dissolved in it. Okay, under high pressure. Remember carbon dioxide, but very low concentration. So even though carbon dioxide is an acidic gas, but it's a very weak acid alcohol, so it's not, it doesn't affect you. So is it possible to make use of the oils without dissolving it? Yes. Yes. Have you not seen those oil that they used to sell 1,000 or 500? It's like one tiny small bottle. They just put it on your body. They just put very small concentration so this fragrance can travel. So just drop it on your shirt like this, and you'll be happy you did. So is it possible to? Yes, they use oil. They're actually quite expensive. Those oils are really, really very expensive because they last longer. In the alcohol, they just put small quantity of the oil inside and it is dissolved. They now be spreading it. So what kind of alcohol? Something like vodka. Yes, actually yes. So methylated spirit is also the rare methylated spirit that are used in treating yourself. It's also an alcohol. Please don't drink it. You get blind while drinking it. Okay. Let me see more questions, sir. Is ethanol the same as alcohol? Yes, that's the commercial name. They call it alcohol. But as a chemist, you have to call it ethanol because, don't worry, very soon, the next topic after this water and solution is organic chemistry, and we are boiling deep down. Okay? So no guy is ethanol. So what kind of alcohol is vodka? Vodka is alcoholic beverage. Is an alcoholic beverage, so it contains about 45% alcohol. So imagine the normal hand sanitizer contains about 60% alcohol, while your vodka is 45%. So vodka cannot even kill your. See, people that are drinking vodka thinking that it will stop their coronavirus, they lie. You don't be deceived. It's 60%, and before you take 60%, that means you are using methylated spirit to wash your hand. So that one is 95%. Okay, so can any solvent remove Zobo ink? Zobo is an organic solvent, so use ammonia or borax solution. Chetemi and her perfume. Okay. Hey guys, we have about 1 minute. All right, I think I've taken a lot of questions from you guys. Yes, so that is the end of solvents, and we have about a minute to go. Now, these are assignments. Take note, all these assignments that you are seeing in these notes, you are to do them in your school notes, where you have to submit them when we resume. If you post it online, they copy it, and you happen to be in my class and I see that it's copied, I'll just assume that you fill them and copy. So please don't go and be posting your assignments on the Microsoft Teams, And I hope you guys had a wonderful session with me. I appreciate all your efforts. August, you're not resuming in August, you're resuming at the end of May or even mid-May. Trust me and trust God. So it's been a wonderful time with you guys. See, I will.
You too, sir.
I will save the note.
Hi.